Charles Law is on page 4 in your practice packet, and I'm going to give you a moment to just write down a few of the important formulas and conversion factors that you need to solve these questions. Go ahead and cross out question A. So don't do anything to the space below it on the worksheet if you've printed out the worksheet, and if you have your own sheet of paper that you're just writing this out on, do not write out question A. Question A doesn't involve any math whatsoever. It's strictly conceptual. I'm not going to ask you a question like that on the test, so we're just going to skip it for now. But here is your formula for Charles Law. Remember, it's V1 over T1 equals V2 over T2. Your temperature, whether it's the initial temperature or the final temperature, must always be plugged in to your formula as units of Kelvin. And so I brought over from your formula sheet your conversion factor for going from Celsius to Kelvin. So remember, you take your degree Celsius that you would be given in the question, you would add 273, and that's now your answer of temperature in Kelvin. And one last conversion factor in case it comes up. Anytime that you're dealing with volume, you're going to have two common units. You're going to have either the unit of liters or the unit of milliliters, and you could be asked to convert between both. So I wrote out your conversion factor for milliliters to liters, liters to milliliters from your formula sheet. And so when you're looking at your formula sheet on the very first page, all those conversion factors are written on that page for you. That's where I got that information from. So your conversion factor sheet is the very first page in your packet. If you notice, all the information that we just talked about is present for you. Here's your milliliters to liters. Here's your conversion from Celsius to Kelvin. And then lastly, there's your formula for Charles's law. And so looking at page 4, going back to the question that we're focusing on today, we're going to focus on question B for right now. I want to make things a little bit smoother for you, so I'm going to ignore some of the information that they've given you in the question, just because it's not going to be necessary for us. We're going to focus on just plugging in the information. So again, remember your formula for Charles's law is always V1 over T1 equals V2 over T2. And you're always going to want to take your degree Celsius, add 273, so that you can get your units of temperature in Kelvin. And there's always 1,000 milliliters in 1 liter. So in the question, it starts off with the first sentence as just background information. The real part of the question begins right here with the word calculate and ends right here. So just some background information. Any sort of aerosol spray can, oftentimes they have a warning that it shouldn't be heated over to a certain temperature or it'll explode. So they're just giving you an example that you have an aerosol spray can and it has a warning on it that says the entire can should not be heated to over 130 degrees Fahrenheit because the can could explode because there's going to be an increase of pressure as you increase the temperature. So what's important for us is the actual part of the question. And so that part starts here where it says, calculate the potential volume of the gas contained in a 500 milliliter aerosol can when it's heated from 25 degrees Celsius to 54 degrees Celsius. Notice that I stopped highlighting at a certain point because the rest of that information in the question doesn't really apply to us. It's not going to make a difference in terms of how we solve it. 54 degrees Celsius is the same thing as 130 degrees Fahrenheit, which is pretty hot. Where it says right here, assuming a constant pressure, I'm going to go ahead and cross that out because that's not going to make a difference in terms of any information you need to know or don't need to know to solve this problem. So first thing I want to do is I want to label what information they give me in the question in terms of who's what variable. So when the question says calculate the potential volume, that means I'm going to be looking for a volume. I don't know at the moment if it's V1 or V2. Calculate the potential volume of the gas contained in a 500 point milliliter. That's my confirmation. That's a volume, because remember, volume is going to either be in milliliters or liters. When that can is heated from 25 degrees Celsius to 54 degrees Celsius. So let me read that one more time and start labeling information here. Calculate the potential volume. So potential volume often means what you could be, right? So that's going to be your final volume, but let me just keep reading to make sure. Calculate the potential volume of the gas contained in a 500 milliliter aerosol can when it is heated from 25 degrees Celsius. So if I'm heating from 25 degrees Celsius, this is the temperature I'm starting with, to 54 degrees Celsius, this is the temperature that I'm ending with. And so what happened is they're telling you you've taken this 500 point milliliter can, so this is the can that you're starting with, and you're heating it from 25 degrees Celsius. So originally it's hanging out as a 500 milliliter can at 25 degrees Celsius. You've heated it up to 54 degrees Celsius, so that's your T2. You're now trying to find the potential volume of it, so that's your V2. So that's what you're solving for. I now know that I'm solving for V2. This is the one that I'm solving for. So in order to do that, I need to get rid of T2 that's in the denominator, because I want to get V2 by itself. And in my question, in my formula, I have V2 divided by T2. So the opposite of dividing by T2 would be multiplying by T2. So that means I have to multiply on both sides of the equal sign, because what you do to one side, you must do to the other. And now, I have T2 in my numerator, T2 in my denominator. These guys are going to cancel each other out. And my T2 is going to get multiplied to my V1, and all of that is going to get divided by T1. So when I go back to my question to set up my formula, my V2 is going to equal T2 times V1 over T1. Let's say you wrote it out as V2 equals V1 over T2 over T1. These mean the exact same thing. They're both correct. I'm just going to stick to the first way that I wrote it out, because that's how I went ahead and set it up for you. So now let me go ahead and plug in all my information from my question. If you guys notice, I isolated my formula first for the variable I needed, and now I'm just plugging things in. That is the ideal way for you to do any of these questions. So my T2 was 54 degrees Celsius. Remember, I can't use Celsius, I have to use Kelvin. So I'm going to go ahead and convert it within the formula, which is the only way to do this. You can't convert it outside the formula and then plug in your answer. You have to go ahead and set it up in the formula, just like I'm showing you right now. So 54 degrees Celsius plus 273, I've essentially just converted this to units of Kelvin. I'm going to go back now and multiply by my V1. My V1, remember I labeled that from my question. My V1 was 500 point milliliters. So that's now my numerator. I can go ahead and move on to my denominator, which in this question, I'm going to have 25 degrees Celsius. Again, I have to get it out of Celsius and it's to Kelvin. So I'm going to say plus 273. And so just like last time, adding 273, I'm now in units of Kelvin. So I'm doing that to confirm for us my remaining unit for my question. If I have Kelvin in the numerator and I have Kelvin in the denominator, those two units have canceled each other out. The only unit I'm remaining with is milliliters. So if I go now to my calculator. Back at you with 327. That's your answer for that part right here. You don't want to write that out. You want to go ahead and just take that answer and multiply it by 500. And so once you do that, your numerator answer is going to be this exact number. You're going to get 163500. So once you do 54 plus 273, and then you multiply that complete answer by 500, your calculator should be staring back at you with this number. When you go to your denominator, 25 plus 273, that's just going to equal 298. So now, when you take 163500 and divide it by 298, you're going to get a pretty long decimal value. When you plug this into your calculator, and I really hope that you're doing this at home as well and checking your work with me, you should get 548.6577,181. Here's some important information about sig figs for this units. You're never going to use temperature as data for sig figs. So let me write that out in a way that you're not going to forget it for a quiz or a test. You're never going to use temperature as data for sig figs. So this is really critical for you, because if you do use temperature as your data for sig figs, every one of your answers is going to be incorrect. So please be mindful of that. Let me go back to my calculation answer here. Since I know to never use temperature as data for sig figs, I'm not going to look at this 25 degrees Celsius because I'm not using temperature as data for sig figs. I'm not going to look at this 54 degrees Celsius because I'm not using temperature as data for sig figs. This time around, I only had one piece of data, which was 500 point. So that means my sig figs is 3 sig figs. If I go to this question and I need to deal with 3 sig figs, that means my 6 is going to round up my 8, and my final answer is going to be 549. My remaining unit was milliliter, so that's my unit, which works out very well because milliliters is a unit of volume. The reason why you never use temperature as data for sig figs is because, remember, your units of temperature must be in Kelvin. So when you were dealing with temperatures of Celsius, or let's say that you had a question that gave you temperature of units of Fahrenheit, which for us, I will not give you, we will strictly be dealing with temperatures of Celsius, that can't work for gas laws. Gas laws must be plugged in as Kelvin. These are how the formulas originated. So when you're using Celsius, it wasn't part of the math involved to create these formulas. So that's why we're never using temperature as data for sig figs. So hopefully you're comfortable with this part and you're understanding why we're getting the 3 sig figs. 549 milliliters is your final answer for question B.